Welcome to Wickerson Studios. It is the 18th of January 2021, and I have my first 25 Wickerson Studio um, user objects available to share and show. And I'm just going to take this one through a little iteration because it uses a multiple function to actually have some control over some very cool things. And I've got the count very low now, but you'll see how that kind of passes its information, and you have control over these wonderful forms. And if you don't like those shapes, you can always go in and customize and change every shape whatever you want. It's basically getting in the habit of using multiple attributes or parameters for functions and making them work. And I'm just using some simple lofted circular forms on the surface of any surface you want to bring in. So the surface itself can be, customized and changed. And if you were to move that or change that surface and import that, then everything has to update to that. So very cool, but the main point of it is get in the habit of learning functions. Now, what I've done here is I'll take this one off and disable it and show you that I've been going through this kind of master file of the first 25 functions that I intend on using, which basically produce point clouds for the most part, but now things are getting a little trickier. And I've ridden through the first 10 on a video series, the next 10, and now I'm doing probably 5 at a time. 5 a day is about as much as I have time to do. And we'll take a look at what's here. So the first one is, for today, I'll put it on enable. It is dealing with surface geometries, and I've done something a little fun post-node in this one. But you can see that the node script is, I've brought in a point cloud, kept it fairly low at 30 count. I've split the list, given myself some tree data, and in doing so, the tree data and then flattening forms, I was able to do something with it. But the forms are basically circles that have different radii, and all I did was a little transformation and a loft afterwards from the centroid on each piece, so I could actually just have a very cool kind of strange object floating on a surface. But the main point of that is today we're going to spend time on 3 functions that actually are, I haven't even made these in the Wickerson Studio user objects yet. The scripts themselves are fairly simple, and you get your head around them. This is how you're going to end up dealing with bringing in data trees as information. So you have multiple things that you have to control. So you're going to produce. I produced 2 lists, and I just appended 2 different circles. But you'll notice that for plist in pt.branches, you're going to process all of those branches, and it's a fairly simple script to do so. And usually the script would just run circle A and appending circle A, and then you can run that list. And if you take a look here, it says this component ran only once for all of that data coming in as a tree. So it processed it as a list of lists. So hopefully that makes sense to people, and that's a nice way to start scripting and start using your tree list and start generating trees. Okay, so that one's fairly straightforward. I suppose I could do 10 or 20 a day if I really wanted to. Let's disable that one. Let's go into the next tree data. And this one I've got labeled. And I don't have the labels on here. Maybe I should bring up my bifocal tool to show you that that was basically what I custom named that one. Oh, I thought it would have come up. It's not going to come up if I don't group it. The name of that function is tree access iteration. The next one is it's going to be tree access conditional iteration. So what's happening in this one, as we bring this one out and enable it, you'll see I have a tool that's, what I found was as single inputs, it was fine. And you can see that that middle circle skips that one. Now, if I bring in multiple data, if I bring in another couple of number sliders, let's say like this, it processes it in an interesting way. I did not mean to do that. I just wanted to select these 2, copy, paste. And if I wanted to bring in, say, another point to make the circle bigger, and I'll hold down shift and put that in the X, so the conditional is saying if X and Y are equal to this, you get another one. You'll notice you get that middle circle now, because this middle circle is coming from this script running and putting a circle on every other script, and this circle, inner circle, is coming from that one running and putting it on that one. So I wasn't too happy with that setup. So I actually went in and I enumerated and decided within my script I'd balance it out. I wrote a script here is one that I found pretty simple online. I just changed it around a bit. I added an else function, and I decided that I wanted to use an and function, I believe, in here. Yeah, if X and Y are equal to I and J respectively, or they're equal to J, that would come out as 2 different bits of information. So that pattern with an enumeration in there is true and false. I've just put a little steroids on the script that if I toggle that over, you'd see I get that whole script, and then I can start to balance that as in size and scale. And I also have the ability to do some pretty interesting optical patterns with that, which I find pretty exciting. And I also have the ability to move and have control over those as a list within there. And you'll see that all of those function not to produce the circle in the middle because they're running as a list. So hopefully that's kind of fun. And you can think about that as a conditional tree-access conditional iteration. Now, if I turn these over to and I'll just show you quickly how to do that because I meant to show that as an example. If we take this one and grab the title, and this is tree access, and then I go over to my file and I hit create user objects. I've already got it set up that it's nearly set perfectly. I'm going to call this tree access because I have a few of them coming out there, and I do have an icon on my desktop, which I'm just going to grab. And then I can go and choose that icon, whatever color I want. And now when I hit OK, it's going to open up and pop on here as long as I get the right one. That's my GH-Python. I need my Wickerson Studio ones. I have objects that are compiled for me, my computer only, so I can use them. But I also have these for the public. So there's the tree. And you'd bring that one in now and make sure everything's running PT. And you could just quickly do a Control-Shift. And actually, you can scrap that one now, and you can put this one into the group, add to group, and take all your data and information into your X and your Y's and your Boolean toggle into your enumeration and your radius A and your radius B. And there you go. You get your script up and running, and you have your own shareable plugin. Well, sort of just a user object that people can see in and go look at the script if you want. You could passcode it and screen it if you want. So I should be doing that with each one. Similarly here, I would just go in and say, this is a tree axis iteration, copy that. We'll do it one more time just so you can see how it's done. Create a user object, put the title into that user object. This one is tree axis as well, so it's still there. I will have to go in and grab my icon. Oops. And then I'll just pop it into my orange. Actually, I think that's a little darker than what I want. I want the bright orange. And I hit check it over one more time, and there you go. Got another tree access item. And you can just grab that one, which was the access iteration, and you can Control-Shift all this data down into there, and all this data into there, and all this data into here, and this data into here, and this data in here. And now your Python's gone, and your nice little user object with your name on it is there. And you feel like you kind of own it. It just doesn't look like a Python. And you're creating your own ribbon tools. Anyway, enough of that. Let's go into 23 because I wanted to get through 25. I never really know what the script is going to be to these things, but here's 23. And this one will jazz on, enable. And I'll give these first 25 scripts in this master script for you to play with for anybody interested in signing up for the Patreon. I have it starting at a $3 fee, and it just climbs for more interaction with me. And you can see how I kind of put a lot of these very simple scripts to use. Now this one's called tree access curve closest points, which is something you probably want to use quite a bit. You'll see this geometry is pretty hard to understand what's happening there, but I've built some really cool geometries. And you find out with the functions, you end up building these little programs. So I took these squares, I took the points, I flipped it sideways, so I had the grid pattern going into the z-axis, and I also have it flat on the xy axis. And then I took those points as multiple lists and processed them as a tree axis curve closest point. Now this script I had to find online because it is pretty complex. You've got to set things. This little -1 really catches it for the minimum distance being lower than 0, like a negative number. How can distance be a negative number? It catches it the first time, and it will basically initializes your minimum distance, and then you're able to find whichever distance is smaller. And so you understand the logic running through there. And there's a lot of for, if, else if. And if you can get your head around that and end up finding that closest point, it works its way down to whatever tolerance you put in there. And you'll find over here, what I ended up afterwards was pulling it to a variable pipe, which I could change and cap. But really the script itself produces some very nice lines. And what I liked about that is because of the way those curves are finding the curve is closest point on, like just think about it. If I was doing a rotation here in the axis and the angle, what happens if I grab, pi, because I like dealing radians, and I grab that and I put it through a little range tool. Well, I wouldn't want to do a range. Let's just do 0.2.0 because I've got. You don't want to make your scripts too big to begin with. So let's take a little rotation on here and get that moving. Now that's processing the script, and I think I probably fudged it out at the 0, but let's see what happened. There we go. I've got a little bit of ability to roll that, but it takes a little while for the script to go. So now that I'm controlling that, it should be an interesting little pattern that I've changed, and it might slow down a little bit. But otherwise, it produces wonderful length distances as I change this. The numbers have to move as to what they were doing. And I think that pi rotation slowed it down a little bit, but you can see it's still working. And it kind of drops off and doesn't work at too low a value. So, or I don't want to set this to 0. So I just put on some pipe there, some fast-moving square pipe on mesh. And I think it's kind of an interesting geometry of actually building this mechanism that kind of rolls around. It was moving faster before. I think what I'm going to do is take out that and this and see if I can't make that move a little quicker, because it was moving pretty fast as a variable pipe before. There it is. Well, it's still moving kind of slow. I'll have to check the profile, or maybe it's because there's other files open. Anyway, you're finding closest points between curves, and I just built an interesting grid system, so that function literally does that. And we were practicing that earlier on some easy as closest point items on 2 curves, but to start to apply it as a function into this actual function is really nice. And actually, it's not a function; it's just a script. But something interesting to start with and get you thinking differently. And of course, I could take those variable pipes up in scale, think of those manufactured, and you can optically get these kind of simulations now through scripting and programming and decide what you want. Let me just zoom in here and see if I can't get that moving a little better. Yeah, it's a slow script now because it's processing too many. Maybe that's it, is I just got a few too many on there. If I took the count, well, the grid has its set for how many cells that it does. It breaks things into 5 sets of 5 cells, so that's what it's processing, those different cells. Anyway, I do like to play with the scripts. I don't just want to show you a Python script that's kind of boring to see. It's when you start. Oh, and the main thing with this is I wanted you to see that for plist in the P tree branches, you've got to nest another loop to go to the points within the P list that are within the P tree branches. And that's how you get deeper into this and find out how to find the length of those point list items and ensure that both lists or the curves aren't the same. So you get your not operator right there. Yeah, and you're just finding the distance between them, and then you kind of edit down from this if-else statement to the shortest distance. So really, that's where you're starting the process. Now, it's nice to bring in tree data and process tree data. It's another thing to start outputting tree data, and we'll get to that later. Jeremy Graham does a great job like that online on LinkedIn Learning. I think I'm rambling a bit because it's the end of the day and it's Monday. Let's grab this next one, and what I probably should do is take this one off. I hope you find these scripts kind of playful and interesting. This one is enable and just move it. Oh, this is a wild one. All right, here we go. Maybe I don't want to see everything. Let's just take those all off to preview off, and then just see the objects I made. And what I did, because I love the variable pipe with parabola, it just jazzes up lines. Like, think about it. There's a line, but with a little bit of variable pipe, you start to optically have a very cool thing. And this script's working from just changing the box frame. So if I alter the box, I've got that plugged into similar data, or at least I did, but then I changed it. I can change the scale of the box, and in doing so, it affects what's happening here. And I also have radii of the circles so that I can play with the inner circle. You'll see here it's got a few to play with, so my count's at 100. So I probably should be sensible whenever I'm playing around trying to find geometries. I like throw in a little 12. Usually whenever I have a choice of 100, I type in 12 because it just makes it for easier computation. So there's the 12. And taking that up and down, I can play with those kind of homemade variable pipes, and I can rotate them because I have them controlled on a vector. And that vector data is going in there. And what's very interesting is it's actually producing a number count of these lines. If you take a look here, as they radiate from a circle. So if I have 8 or 10 or 3, whatever I put on there, those are the lines that are being lofted. But what I liked about them was you could have control up in different directions. So you can really bend those and pull them and flash them out and have the vector controls on where they're going and where they're moving. So it's just it's just a playful thing to start getting to some geometries. And there you go, some nice little pattern geometries floating around. And that's if you like multiplicity in your work. Anyway, the main point of that function was to get you nesting in your list into your tree data, and that well, that was the last one. This one's actually getting right into the functions of iteration. You'll see exactly what happens within a function. You've got to write it, first of all, do your imports, and you'll see up top you have the function defined. And I defined it as drawing a spiral. And I had the two radii, and even though I didn't have to do this, I could have just left it radii B, and ousted this whole thing because it's actually being inputted right here properly. But I think because the R1 was in use in the function where I found it, then I was just, let's just leave that in there so I didn't have to change all those names. I could just change it up here to another thing I wanted to call it. And what it does is, in drawing the spiral for I in range, counting of the number, as many as you want, which I've set as well as a number and a single item integer, then I can calculate a vector at R1. I can do a rotation on it and have it jazz. Now, this was hard-coded, but I didn't like it hard-coded, so that's why I brought in XYZ in my own vector, and I actually tied the vector. That's where it gets parametric. The vector controls are similar to choosing the size and scale of the box. So that's something you're doing outside in a grasshopper kind of way, whereas it's not really within the script itself. But I didn't want to have those hard-coded. I try and get rid of all number hardcodes that I can, unless it's kind of a simple multiplier or something like that, like pi times 2. And then the math behind it isn't too hard to handle the vectors, and then add to each vector as you go and produce a line. And once your lines are there, you append that and return that line. Now, what happens is that has to be created as that list, an empty list, which then, for the amount of points in the points that you've dictated right here from your region tool, or your cluster, or your what are those things called, point clouds, then basically you can just run that script as many times as you have those points, and you extend that list every time you do it. So you're not appending it, you're extending that with the lines that are produced, and that's what you're actually returning, is lines from that function. So very cool. If you look at the main, you think of running these functions within it and processing that, and then if you take a look at this, it's a wonderful function because it's just processed once, and then for each point that's generated. So here it is, 120 lines that come out, and then I made them into those shapes. So you're starting to think functions, and functions should start to make you think a little more movement, a little more four-dimensional in your programming, and that's where I kind of go with it. Now I have another function here that has 3 attributes, or at least started with 3 attributes. I might have added more. This is the last one I'm going to show today, and this one is called, it's the one I started with, surface function surface objects. So you can take any surface you want, and you can manipulate that, really anything you want. I do like quad spheres. I might pop it over onto that. But it's a pretty clean system. It is very nice, and I was very playful with it. So as I started going on here, I added caps afterwards. I could have added that in the script, but I didn't. The surface, it's dependent upon this surface. So if I look at everything there, I've got surface selected, or I can select this. I can cap them afterwards and just look at the final cap forms. But you have some really nice control on that surface. Not only counting in this direction, you can, and you'll see how it kind of do-si-dos and tries to get off the screen. But whenever it gets too far to going off, here we go. This is the more interesting side. It's going to bounce as soon as it hits the top. It's going to come back on the bottom. And I really like this tool, kind of like a waving flag. And I have control over manipulating that, but I also can complicate it by just bringing in tons of items. And I like that they're scaled smaller as they go. And as this kind of shift happens in the V, you're not going to really, that's not even the V shift, but that's the count. If I start pulling up this shift in the V, which is a very small number, it's just going to keep moving that up. And it's hard to appreciate what geometrically is happening when you have too many on the board. But if you bring this one down, you'll see exactly what's happening. It's taking all the pieces and slowly, through multiplication, bringing them up at different rates and then popping them on the bottom again. So kind of a nice little tool. I like that. Everything else is just for visualization and changing shapes and little bulbous little mushroom phalluses. Have some fun with those things. All right. And then the last one are the scaled probability. If it gets too low on this count, it busts, but that's just because the smallest one gets too small to make. And let's take that off. And then if you go high on this one, it'll bust because you get too big. It'll shrink it too much again. So you get it. There's a happy medium of where your numbers can be. And like I said, those were hard coded in. And I kind of look at anything that's in a decimal between 0 and 1 as a probability, and I call it a high, low, or mid probabilities, and that gives me an idea of what to set things at. So when you're stuck with a cluster like this, especially when it looks crazy, so let's just do this for function surface objects. Let's just grab that. Let's grab this one. Let's go up here and grab our user objects, function surface objects. There we go. And let's have a new category called functions. because we're getting into some now. Let's just grab our icon, and let's do-si-do over here and there. Well, we should have an icon function now that pops up, and there it is, F right there. So we can pull that one in, connect this to the out, and you're still left with your out for debugging, as opposed to compiling. Whenever I compile things, then I have trouble losing my data and getting back into it. So I don't really like that. So because I am about sharing knowledge and teaching, I don't know if I have to keep things really hidden. But if you're interested in these kind of Wickerson Studio unique plugins, this document saved, just sign up for the Patreon. I'll shoot you all 25. You definitely can try and watch the videos on YouTube for free to get all the access. I'm just going to keep going until I'm blue in the face. And that is a long 20-minute video. I also will send you all the user objects as well, because they are not just in Python, which is what I'm running the Wickerson Studios in, but if you are interested, I really do recommend having a look at the Patreon site. There are tons of C scripts. All of these are C script. It's only the WSs that are Python. Everything else is functions, nodes, algorithms, and everything that I've been using to build a library of going into C and being able to really customize my ribbon tools. So between ARA jewelry, C# nodes, and Python nodes, and then the basics, I really avoid a lot of the plugins. I've got a couple of them on here, but I don't use them really at all. All right. So thanks very much for watching. I hope you find this interesting.